Hello. For part 2B for the homework, for part 2A of the homework, we can explain in code the secant and Newton method for finding the roots of a scalar 1D function. So what is the secant method? Let's Google that. Let's go on Wikipedia. Basically, the secant method is a root finding algorithm that uses a succession of roots of secant lines to better approximate a root of a function f. The secant method can be thought of as a finite difference approximation of Newton's method, which is we're going to be using in the second part of this video. So we have this is the Newton's method that we are going to use. As you can see, the x of the value minus 1 with the function of xn minus 1, and then you just subtract the first 2 points to find the other points. So this is the whole derivation of the method. As you can see, we have our first guess, which is x0 and x1, and then from there you're able to get this line. Then you're able to get x2. And from x2 and x1, if you get your guess, you're able to get this. And eventually we'll find the root of the function, which is basically at like a point around here. Not sure where, but I'm trying to explain it graphically. So in order to do this, we are going to need to create a function. So we're going to call this function secant, and it's going to take in a function f with the initial guess of x naught and x1. And then we want max iteration. We want that equal to 50. So we don't want it to iterate a billion times. So we're going to need to pick a certain value. So we want the tolerance to be 1 to the negative 10th. So we want the first value, f of 0, to be the function of f of 0, of x of 0, the first guess. And we want f of 1 is to equal the second guess. And then we want to loop this with the iteration of max iteration. And we're going to enter that formula that we're going to want to iterate through to find the root of the function. So this is the formula that I'm just entering. And then we're going to want to call the function of 2. We want it to have the second guess, third guess, because I guess x0 starts from 1, 2, and 3. And then we want the absolute value of f2. We want it to be less than the tolerance. And then we define tolerance up here, as we can see over here. We said it was 1 to the minus 10. And we want it to break. Now we want the first guess to equal the first value. We want the first value to equal the second guess. I don't know why it keeps doing that. Enter. And then we're also going to need the function of 0. F of 0, we want to name it into the first x of 0. And we're going to do that with f1 as well. But we're going to put it in its second value. And then from there, we're going to return x2. Where did this come from? I did not write that. I guess that was from something else. Okay, looks good. Now let's define a function of f of x. And we want to find the root at x plus minus 3. So we want the root at minus 3. And then we want the root at plus 2. And we want the root at plus 8. So we're going to find the root at all these values. Okay, so now we're going to need to make it into a list because we want to graph it and see what we're looking at. We're going to do np.lentspace. We're going to find it at negative 0.5 from 1 to 50. And then we want the y part of the list. We want that to equal the f of the list. And then now we can make our graph. So we're going to import to make the subplots. Let's see if we, yeah, we have it there. And then we're also going to do figure.add scatter plots. Scatter, no, it's not scatter plots. X equals X. We want the list that we made. And we want to define the X and Y axis as respective of what we made them. So we list. So, as you can see, at negative 3, we have one of our, at negative 3, we have one of our roots. And then at 2, you can see we have another root. And then we also can see at 8, we have another root. So let's just return one root. Let's call that secant function. Let's say f is equal to f. X of 0 of the first guess. Let's say it is negative 0.1. And then x equals 0.1. Well, we have to say it's the first guess, I assume. So you got 0.19, which is 0.2. And you can see from the plot, we also had a root at that one point. Okay, so Newton's method is a method for finding the root for a system of equations. The idea behind this is to start with the initial guess, which is reasonably close to the root solution, and then to use it to the tangent line. And then to obtain another x-intercept that is even better than our initial guess or starting point. We want to find the root for f of x. I mean, we want to find a in the picture below. So we want to find this, and we're just going to keep having guesses until we get a linear approximation of what that value is supposed to be. So we're going to use a Newton method's formula, and we're going to create a function to graph it out. Now, okay, So let's define that function that we were just addressing. So it's going to be the same, but now we just want one initial guess. We want the max iteration. Let's say it's 50. And then the tolerance, we'll say 100. And then tolerance, we'll just say s before 1 to the minus 10. Okay. Now we want to find the f prime. So we're gonna make a call f prime. Something buzzing on my phone. Okay, it's still going on. F prime jax.grad f allow integer equals true. So what we're going to need is we want to find the f prime, so we're just going to find the gradient of that. And then we want to also find it of f0 equals f of the first guess. So we're going to do what we did above for I in range of max iteration. But this time it's going to be a little bit different. We're going to find the first guess. We're going to input the equation that we need to use. With the first guess. And then we're also going to need to find the function of 1 f x1. And if the absolute value of f1 is less than the tolerance, then we're going to need to break it. So we need x of 0 is equal to x1 f 0 f of 0 I kind of forgot what I had to do here. Oh yeah, like before, we want the first guess to be equal to that guess. And then we want the function of 0. We want it into that function of 0 as well as with the first guess. And we want to return x. We want to return x1. Huh. It did that again. It's weird. I don't know. Maybe my thing is being weird. From 6 import b. What does that even mean? Whatever. It's still working. So let's call the Newton to find the Newton method. So this is from 1 point, not like point 2. So we found the secant method to find the root, and we found the